Before you speak a single word, your dog already knows how you feel. Your body leaks chemistry. Fear, stress, calm. Each state produces a distinct cocktail of volatile organic compounds that drift off your skin and breath in real time, invisibly, constantly. These are called chemosignals, biochemical messages your body was never trying to send. They're byproducts of your nervous system doing its job, and dogs have evolved specifically to intercept them. A dog's nose contains roughly 300 million olfactory receptors. Humans have about 6 million. That ratio isn't a minor upgrade. It's a fundamentally different relationship with the chemical world. The portion of a dog's brain dedicated to analyzing scent is proportionally 40 times larger than the equivalent region in a human brain. Smell isn't one sense among many for a dog. It's the primary sense. Dogs also carry a second chemical detection system, the Jacobson's organ, or vomeronasal organ, positioned at the roof of the mouth. It detects non-volatile compounds, heavier molecules that linger on surfaces and skin. Here's where it gets genuinely complicated. Detecting a chemical and reading an emotion are two different things. For years, researchers assumed dogs were reacting to smell intensity, not emotional content. In 2018, a team led by Biagio Daniello at the University of Naples published a landmark study. They collected sweat samples from humans experiencing fear, happiness, and a neutral state, then exposed dogs to each sample separately. Dogs exposed to fear sweat showed measurably higher heart rates, sought more reassurance from their owners, and were less willing to approach strangers. The smell of human fear produced fearful behavior in the dog, without any other cue. Dogs exposed to happiness samples behaved differently, more playful, more socially engaged with strangers, lower stress indicators across the board. The emotional signal traveled through chemistry alone. The primary chemical involved is cortisol, the stress hormone. When cortisol surges in your blood, related volatile compounds appear in your sweat, breath, and tears within minutes. Dogs detect these downstream signals, not the hormone itself. Adrenaline adds a second layer. It triggers the apocrine sweat glands, concentrated in the armpits and groin, which release a chemically richer sweat than ordinary cooling sweat. This is the specific sweat dogs are reading. Most people focus on fear. But here's the counterintuitive finding. Calm also has a chemical signature, and dogs respond to it just as clearly. A relaxed human produces a distinct scent profile that dogs associate with safety. Oxytocin, the bonding hormone, rises during calm, affectionate states and alters the chemical composition of your breath and skin secretions. Dogs living closely with humans have learned to recognize this signature across thousands of generations. This didn't happen overnight. The domestication of dogs from wolves began approximately 15,000 years ago. That's 600 human generations. Enough time for selection pressure to sharpen dog sensitivity to human emotional chemistry, specifically. The oldest confirmed evidence of dog domestication is a burial at Bonn Oberkassel, Germany, dated to 14,200 years ago. A dog interred alongside two humans, suggesting a relationship already intimate enough to warrant shared burial rites. Dogs that could read human emotional states more accurately were better fed, better protected, and more likely to reproduce. Over millennia, the ability to decode human chemistry wasn't a bonus feature. It was a survival advantage. But here's a question most people never think to ask. Does breed change any of this? Are some dogs chemically sharper readers than others? The answer is nuanced, and it reveals something specific about how the skill actually works. Scent tracking breeds like bloodhounds have more olfactory hardware, but social attunement to human emotion appears consistent across breeds. It's a behavioral inheritance shared by all domestic dogs, not a specialist trait confined to working lines. Dogs aren't reading scent in isolation. They're integrating chemical information with visual cues, your posture, your facial expression, and auditory cues like voice tone. Chemistry is the first channel to open. It sets the frame for everything else. A 2022 study by Clara Wilson and colleagues at Queen's University Belfast found that dogs could identify stress-related cortisol changes in human breath and sweat samples with 93.75% accuracy before any behavioral signal was present. 93.75% isn't near certainty. It is near certainty. That beats most humans at reading emotional states in strangers. Your dog isn't guessing. It's measuring. This is precisely why medical alert dogs work. Dogs trained to detect diabetic hypoglycemia are responding to isoprene and other volatile compounds that shift in the breath as blood glucose drops, a chemical alarm that precedes symptoms by several minutes. Dogs trained to assist people with PTSD interrupt panic responses before they fully escalate, because the dog detects the adrenaline and cortisol surge chemically, seconds before the person consciously registers the anxiety themselves. Here's where it gets stranger still. The chemical conversation runs in both directions. When your dog detects your stress and becomes stressed itself, you detect that shift unconsciously through subtle changes in the dog's own scent and behavior. Research consistently shows that interacting with a calm dog lowers cortisol in humans. Petting a dog for 15 minutes measurably reduces blood pressure and raises oxytocin. The chemical loop isn't one way. It's a shared regulation system. Think back to that dog asleep at your feet. It isn't simply resting. It's monitoring. Every exhale you produce, every small shift in your skin chemistry is being processed by a sensory system built across 15,000 years of living beside you. Most people never register this. Your dog's sudden attentiveness, its decision to press close, its quiet check-in with a nose to your sleeve, these are often responses to chemical signals you produced before you consciously noticed your own stress. The dog isn't reacting to what you did, it's reacting to what you secreted. In a 2019 study published in PLOS One, Kirsty Meinz and colleagues at the University of Lincoln found that dogs showed measurably increased attentive behavior, sustained gaze, proximity seeking, reduced activity, within 90 seconds of their owner's cortisol rising, before the owner displayed any visible behavioral change. The dog wasn't reading the person, it was reading the air around them. This reframes dog training entirely. A trainer who arrives anxious communicates anxiety before speaking a word. A fearful child approaching a dog sends a chemical invitation for the dog to respond fearfully. The emotional environment is the first training variable. The bigger implication reaches beyond dogs entirely. Humans also produce and receive chemosignals. We're simply less conscious of it. Dogs make the invisible visible because their responses are large enough to observe. Every time your dog shifts position in response to your mood, it's giving you data about your own body that no wearable device currently matches. Here's what you can do with this today. The next time your dog suddenly moves closer, nudges you, or becomes unusually attentive for no obvious reason, treat it as a physiological alert. Pause. Check in with your own body. Your dog detected a stress signal in your chemistry before your conscious mind caught up. It isn't mysticism, it's biochemistry, and it's already happening, whether you pay attention to it or not.